This is 4.1 for pre-calc. Don't pay attention to the 4.2. This is 4.1 out of our book. What we're going to be talking about today is angles in radian measure. So what we're going to learn in this section is we're going to learn to draw angles with standard position. Most of you have drawn angles before, but maybe not from standard position. You may not know what that is. We're going to find coterminal angles, and we're also going to use radian measures. We may have talked about radians in here before, maybe not, but it is another way to measure angles. So let's get into that right away, talking about the difference between degrees and radians. So before we do that, we got to talk about drawing an angle. So in trigonometry, one thing that you're going to learn is that we will always be starting on the horizontal axis for our angles, and that will always be considered our initial ray. So that blue line that you saw that I drew over, that's your initial ray. And then this angle, which is what completes the angle, that is called our terminal ray. So the initial ray is where you start, which will, in trig, will always be in the same spot. The terminal ray is where you end up. And all of those angles can be measured in either degrees or radians, okay? So they can be measured in degrees and radians. So let's talk about the difference between the two. In degrees, this is something that you've been doing your entire math career probably, dealing with angles, is just referring to them in degrees. So like, for example, this angle is 35 degrees, and that's how we represent it. In radians, there's a key way to differentiate between radians and degrees. For radians, it'll just be a number, so like 2. Sometimes you'll see radians written after it, sometimes you won't. But if there's no degree sign, you have to assume that it's in radians. So sometimes radians will be represented as a number, but mostly it'll be represented in terms of pi, meaning there will be a pi as part of the number. So like 2 pi over 3 radians. Okay, and I apologize about my bad handwriting, so you have to listen to me while we do this as well. So let's move on. So let's talk about converting back and forth between radians and degrees, because this is going to be important. Now I know you can't read this on the video, but you can see it on your notes fairly easily. Basically what we're doing is we know that there's 360 degrees in a circle. You may not know this, but we may have talked about this before. There's also 2 pi radians in a circle. So 360 degrees and 2 pi are the same. If you go to 180 degrees, that is equal to pi. So half a circle, half a circle. Now, when we want to go from degrees to radians, say we start with 45 degrees. Our conversion is simply to multiply by pi over 180. Basically, what you're doing is you're taking your degree, you're figuring out what fraction of 180 that is, and then there's going to be a pi added in there. So what fraction of 180 is 45 over, is 45? So we do 45 pi over 180, and this actually reduces 45 over 180 as 1/4, so we can say that's the same thing as pi over 4. And again, if you think of it this way, 45 degrees is 1/4 of 180, put the pi in there, so radians will be pi over 4. And going in the opposite direction, say we had 2 pi over 3 is our radians. We want to go back to degrees. Well, we do 180 over pi multiplied by that. The pi's will then cancel out, and then we simplify. 2 times 180 is 360. Divided by 3 is 120 degrees. Really, really easy to convert back and forth between the two. It's just you have to know what the ratio is, or you have to remember that to go from degrees to radians, you're going to figure out the fraction of 180, and then from radians to degrees, you're just going to multiply by 180 and get rid of the pi. Okay, moving on. Let's talk about actually where on the coordinate plane all of these matter. So when we start, we always start, our initial ray will always start here. That's where our initial ray will start. So therefore, that's our 0 degrees and our 0 radians. So when we go up to this top line, we're at 90 degrees. And then 1/4 of 2 pi, which is pi halves, radians. Over here, we have 180 degrees in pi radians. Down here, we have 270 degrees and 3 pi over 2. That's 1.5 pi. And then at the very end, we have 360 degrees and 2 pi. It'll be very important for you to know these main points, because down here, even though you can't read it on the video, you can probably on your paper. Knowing that this is 0 and this is 90, that will tell you that 30 degrees has to be somewhere in here. 45 degrees has to be somewhere in here, 60 degrees, etc. And then when we get into our 100 degrees will be in here, 150 degrees in here, and then our 250 degrees, and then so on. So it's really helpful to know where all these conversions lie, so that way you know where on the quadrant you're going to be. That's going to be really important when we get into the meat of trigonometry a little bit later. Okay, so moving on, let's talk about drawing angles. So this is from a standard position. What do we do to draw an angle, or how do we know where to start from? Well, as I said before, our initial ray will always be on this axis. So let's say we had an angle of 120 degrees. Well, again, we need to know that this is 90 degrees up here. This is 180, so our 120 is going to fall somewhere in this quadrant. So that's our 120 degrees. We always go clockwise for our positive degrees, and then we go counterclockwise for our negative degrees. So again, we start with our initial ray. Because it's negative 250 degrees that I'm giving you, we now go in the opposite direction. So this is negative 90, negative 180, and then this would be negative 270. So we know we're going to be somewhere in between, and that would be our negative 250. We're not going to really worry about any more. I think that's pretty self-explanatory. Going forward 120 degrees, going backwards a certain number of degrees. You just need to make sure you go the proper amount and go into the proper quadrant. So talking about coterminal angles now, this is important to know where we're at and what degrees we have. So coterminal angles is, this requires you to understand the concept of the initial ray, which is the beginning, and the terminal ray, which is where we're ending up. So let's say we have an angle here that is 50 degrees. That means our initial ray started here. We go up 50 degrees to our terminal ray. What a coterminal angle means is an angle that has a terminal ray in the exact same place. So we talked about a full circle is 360, but really you can go around the circle as many times as you want. If I go all the way around for 360, I can go all the way around for 720, and then so on. I can keep going around and around and around. So if I'm looking for a coterminal ray of 50, what I'm really looking for is what happens if I take this and I go around the circle a complete another time, one more complete turn. Well, hopefully all of you know that that's just a 360 degrees. So if we take 50 plus 360, that gives us 410 degrees. That means that 410 degrees is coterminal to 50 degrees because the angle is in the exact same spot. And you could even add 360 again. If we want to add 360 again, so 410 plus 360, that's 770 degrees. It just means we went around the circle even again. So 770, 410, and 50 are all coterminal. And we can even go in an opposite direction. Let's say we wanted a negative angle. So we go in the opposite direction. Same idea. We're just minusing 360 this time. So 50 minus 360 is negative 310 degrees. So there's a negative coterminal angle. So negative 310, 770, 410, and 50 are all coterminal because they're in the exact same spot. Now, dealing with radians, radians is done the exact same way, except you have to remember that we're not dealing with degrees anymore. So what's a full circle for radians? Well, a full circle for radians is going to be plus 2 pi or minus 2 pi. So for example, if we had 2 pi over 3 and we wanted to add 2 pi to that, we need to make sure we find a common denominator, so the denominator needs to be 3. So 2 pi over 3 plus, and now we're going to bring a denominator of 3 here, so that means it needs to be 6 pi over 3, because 6 pi over 3 is the same as 2 pi. We add our numerators, so we have 8 pi over 3 is coterminal with 2 pi over 3. If we want to get a negative, we would do 2 pi over 3 minus 6 pi over 3, and that would be negative 4 pi over 3 would be our other coterminal angle. Pretty simple, pretty basic idea, but it does require you to understand what a coterminal angle is. That's very helpful because then you understand that all you're doing is trying to get to the exact same position. Okay, so on the next page, there's two problems that I want you to do on your own. Okay, they're coterminal problems. So stop, put in your answer into Edpuzzle when you're done, and then I guess we'll see how you do. For the first one in degrees, the 110 degrees, you should have added 360 and minus 360 to get 470 degrees and negative 250 degrees. For the radians, you're adding 2 pi and subtracting 2 pi, so you need to make sure you change your 2 pi to 8 pi over 4. That's the same thing as 2 pi, but with a denominator of 4. 5 plus 8 is 13 pi. 4 stays the same. So 13 pi over 4 for the positive one, and then 5 pi over 4 minus 8 pi over 4 is negative 3 pi over 4 for the second one. So that's all I have for this section. I will see you in class, and hopefully this made sense, but make sure that if you have questions, you ask.